just got this. It's a John Deere 675B. It actually used to have a door on it and it's got heat in it, but it's in pretty rough shape. So this has a Yanmar diesel motor in it, 4-cylinder. So it was the cheapest skid steer I could find that was diesel. The guy wanted $4 grand for it. I gave him 3. I couldn't even find another diesel skid steer for less than 5 grand, and even that, there was, even at 5 grand, there was only like one, and it was crappy. So I'm pretty happy with the deal I got. For that kind of money, you can make up for that in a week's worth of work. So the first problem that I want to deal with is the bucket and the boom don't really function like they're supposed to. For some reason, if you press the pedal like a little bit, it works great, but if you press it a lot, I don't know, maybe it overthrows it or something, the valve, and then it doesn't really do anything. So I really haven't done anything yet. I just pulled it off the trailer. I just drove it around a little bit. The other problem that I discovered is that I think there's a problem with the one of the, or maybe more of the sprockets and chain that's inside of here. The hydraulic fluid, I guess, bathes the sprocket with oil. So I'm gonna have to take these panels off and figure out if I can see something going on in there. Once in a while it starts grinding, and sometimes it actually just grinds so much you can't even move. All right, so I'm gonna show you what I mean by it's grinding and crunching. Well, that's not good at all. See, there's milk coming out of there. It means there's a lot of water in this hydraulic system. That's not good at all. Alright, so I drained all the fluid out. There's drain ports on like all 4 corners of this thing. So there's one down here in the front, and kind of same thing underneath the back tire here. And the belly on this thing goes all the way through to the other side. So what I did was I put a jack on this side so that this side would be a few inches higher than the rest of it. So in turn, it should drain everything to this side. So this thing has like 17 gallons of hydraulic fluid in the belly here. So I needed quite a few spackle buckets to do that. So I didn't really, here's a magnet right here. And there was a little bit of metal shavings on that, but it wasn't really too bad. I would expect more, honestly, from a chain drive system. So I tightened the chain. That might have been a little bit of the rattle that I was hearing. But as far as the hydraulics are going, obviously this fluid is just completely not acceptable. But in here on the right hand side, if you're sitting in the machine, there's a strainer right here. And that comes from the belly. On here, this is just a 7/8 bolt that you kind of take it off, but it's not a bolt, but it's the top of this thing. And so you just take this out, and it's pretty bad on this thing. And look at that. I don't know if this is from the pumps or if it's from the chain system. It's hard to tell because they're both on the same circuit, so can't really eliminate anything. This is part of the strainer here. The rest of it's right here, and there's even more stuff in here. This is just trashed. That's not really that good at all. It's not good news. The good news is that it's here, not in the pump, but I don't know. I don't think the pump's going to be able to have metal like this going through it and still be good. Well, we'll see. So the next thing I want to address on this is this bucket. This bucket, I think, is too big for this, but I'm gonna make it work, and I'll probably leave it the size it is. I think it's like 3/4 of a yard. I'll probably leave it the way it is for certain things that I need it for. The problem with this bucket is I can't see through it. It's too tall. So from here to here is like, I don't know, a little over 2 feet, like maybe 28 inches or something. And when you have it flat on the ground, when the cutting edge is on the ground, you can't see it because this is in the way. So what I may do is cut a little window in here, but I'm not really sure. I might just get another bucket for everyday use, and this is good for like firewood and stuff. And if I use it for something like that, like lighter materials, I might actually extend the sides up and make the front longer to make it store even more stuff. I'm not sure. I'll have to see how this works for like an everyday kind of bucket. It may or may not work out, but I'm gonna fix this for now. So what I'm gonna do to make this easy, because I don't want to spend a ton of time on this, I'm probably just gonna cut out these sides and replace it with something thicker. But the most important part is this cutting edge here. So I got a new one, and I think what I'm gonna do to make this easy is just take the plasma cutter and cut where this cutting edge stops. Just cut a nice line in here, and then I'll try to straighten out the bucket and then put the cutting edge on. Because if I just put it on top of this, it'll be too thick. I know some people suggest to do that, but it's just too thick. And besides that, the cutting edge separated from the bucket itself, and there's like dirt wedged in there. So I'm not even gonna try to bother to flatten that out. I'm just gonna cut all that out and just put a new piece in. Cutting edge was like $130 at my local tractor store. I got 8 feet. So we'll see how that works out. It's a lot cheaper than a new bucket. So that's what we're looking at. So it goes from 0 to, I don't know, 1.5 inches here. That's how bad it is. So I might have to get creative to bend this thing back, because it's got these supports here. I'm sure they don't want to give up easy. Anyways, I'm gonna get cutting this, and I'm gonna use my standoff on the plasma cutter. It's been a while since I put that on, but I want a nice straight line here, so I'm gonna use this board. I'm gonna clamp it on. Hopefully I can bend it enough where it's down far enough, and then I can follow it to cut this. Alright, so these are the two spots that need to come up a lot. So I welded these little things here just so that I can pull up on it, and then later when I'm done I'll grind them off. I'm just trying to, it's like pulling a dent out on a car except at a much more extreme level. So you just kind of got to look at where it's like creased, where it's bent, and hopefully I got it in the right spot. So what I did is I welded these things on here, and then I pulled up on this, I tightened it up, and I went way past where it should be. And then, so this whole thing was bowed. And then basically as I was welding, it was heating things up and actually helping it to stay in that position. But also, just all these welds that I'm putting in here, as I had this deformed in the opposite way that I needed to be, not only did the welds heat it up real nice to help it stay that way, but what they also did was add some strength from it going like this. So finally, when I let go, it's now, I think it's acceptable. I mean, I think it's, this cutting edge is down about 1/4 inch in the middle and up on the sides. Well, so the sides are where they are. That's where they need to be. And the middle is about 1/4 inch low, so it's just slightly crowned down a little bit, but that's much better than having it crowned up. When you have it crowned up, as much as it's up, that kind of makes like a stop. When you push into a pile, it kind of just like stops. So if it's crowned down, it'll kind of help actually. Ideally it's better to be flat, but if anything, you want the crown to be going down slightly rather than up. So there was just this one spot was really bad here. There's this main like beam right here, and then on the side of it, it was all deformed. So I got that much better. That's, you can't really see it, but it's so much better than it was before, because I pulled it way past where it needed to be, and I had a lot of pulling power with these. I'm just going to keep welding the rest of this. I'm pretty happy with the way it turned out. Also, what I'm going to do is weld the bottom of this when I put it in the air. This is going to have a lot of weld on it, and then I may put another piece of steel on the bottom, just a thin piece of steel, because normally the bucket comes out further So this bucket's made out of, well, I guess it's made out of 1/8 inch. Thought it was a little thicker than that, but I guess not. So usually the 1/8 inch would come out all the way to the end, and then you'd add the cutting edge to it. So I'm missing that whole part of it, so I may just put a small piece of steel on the bottom. Like I said, I'm going to try this bucket out. I don't want to go crazy on it because I can just buy a bucket for like $500. So if I spend like 2 days doing this, that's not even close to worth it. I'm pretty happy with this skid steer. I didn't realize it until after I bought it that it has a 1,700 pound capacity on it. So for this weight on this machine, that's pretty good actually, because a Bobcat of equivalent would be like a 763, and it's about the same weight, but it can only lift 1,300 pounds. So that's the rated capacity. So that's 50% of the tipping load. So you can usually go twice that much before you actually tip. That's under ideal conditions, flat ground, full fluids. So at 1,700 pounds, the tipping load should be 3,400 pounds. So that's how much I can lift, and it can usually, the breakout force is usually a little bit even more than that, but it tips at about 3,400 pounds. That's pretty good for a machine like this. Even a lot of newer machines are only a little bit more than that. So all in, I think I have $3,300 into this thing, and it's on the job site ready to go. So the next thing I need to do to this is change over this quick change, because this is a New Holland style quick change. So I'm gonna adapt that over to the universal. It shouldn't be too hard. Then I can use any bucket. This hole works out great. I can see through. That's about at the height that a normal bucket for this would be. So now I can actually see through, but I can also carry bigger debris if I need to. The sides, I think, probably didn't need to be cut down. I might add something on there later. I just didn't really have the steel at my property when I did it. I didn't have the right steel to do it, but for now, I think this will do for a little while anyways. So this turned out to be pretty good, and this skid steer works pretty good. So really, the only problem that I had right from the beginning, and the reason why the guy sold it for so cheap, was not the strainer here, even though that was pretty plugged up. The problem actually was this valve right here is for the third function. So what happened was this valve was down because this was rusted, and somebody had shifted this. This is the lever for it, and here's the cable. So the cable's no good. I got to replace that. At the end of it, what happened was it got rusted and it just got stuck. So this valve was just stuck on. So there was no power to anything because it was just dead-ending this power because this was on. So to be off, this spring should be hitting this piece of metal right here. And that's where it is right now. And I put a pin in there so that you can't do it again. So it was just dead-ending to these quick connects, and that's why it had no power. So that's all that was. So I kind of got lucky on that. So this is ready for use, and I'll continue using it from here on out. Maybe I'll sell it for a bigger skid steer eventually, but I think this year this will be fine. Maybe I'll keep it around for using it for the sawmill after that, even when I get a better one, because I kind of like it actually. I didn't really care for it at first. It was kind of like a quick, easy machine, but it turns out to be pretty good.